Hi everybody, this is Vishnu Murthy. I'm working with Dell Technologies for last 19 years, and after my graduation I joined in Dell, and I work for a group called Enterprise Validation Engineering Team. Basically we validate the servers before we releasing it to the market. So it's like your typical laptops like that. We actually certify all the enterprise servers what we release to the market actually. And I started my career as a validation engineer, and then I moved into the automation, then I moved into the automation architect. Now currently I'm actually building the tools for the validation organization, so that how it can actually perform better, how we can do the things better actually. So I hope I'll try to connect my talk to relative to your experience and other things. Let's see how we can get beneficial. And if there are any questions are there, yeah, feel free to ask me actually. I'll try to make it more quick, and then we'll go and talk about more on question and answers and all that stuff. Okay. Yeah, I do present in external conferences and other stuff and share my experience and other stuff. Okay. Yeah, I didn't mention anything else. Yeah, what else? Let's get into the topic. So what exactly the server validation engineering team, what exactly we do, and the tool which is basically ICEMAN, what is the full form you will see in the next slides, and we'll give a high level overview of the things, and then little bit more insights about what is the journey of this entire tool, why we built, and all the stuff actually. Okay. Yeah, I mean, maybe if you're looking more technical, we can connect offline and we can discuss, but most of the things what I talk here is it's pretty much open source, so there's nothing like in a confidential, you can discuss anytime. Okay. So yeah, I put picture of Glow so that you can see we are, as I mentioned, the server validation group. We actually have different sites in 3 regions, mostly in Austin and Bangalore and Taiwan. So basically what we do, we actually across these 3 sites, we certify the servers. If you see any Dell server in the market, we actually validate the server. We have different cycles, and we validate every component, every peripheral in the system with a different operating system, different cards, different hard drives, different storage controllers. It's a big, what do you call it, in a test, we have test plans to test actually. So yeah, you can see every server which goes in these 3 sites, some of the site will be certified and validated. Majority efforts we do it in Bangalore, and all the software, firmware, and driver validation, everything happens in Bangalore actually. So okay, I thought it comes up one by one, but it's okay, it comes up. So what exactly the problem statement is that when we do testing, correct, we test, and then we actually see if there is any issue comes up, and we update the logs to the defect, and then we file a defect, then we upload results to the test cases, and then file a test case status, we update it. But over the time what happens, when we are testing multiple systems over the multiple weeks, multiple configurations, there are certain things we may not even store in all these test management systems or defect management system. So what exactly happens is that when we are looking at historical analysis, we can't go back to these typical test management solutions or defect management solutions to check for a specific event we've seen in this testing, or specific observation we've seen or not, because it could be in the log somewhere in the down, but customer is seeing suddenly and we wanted to check. So that was one of the biggest problems we started seeing, because we have so big efforts we do across teams, across regions, across users. So when we are looking for a specific details, correct, after we complete testing, it's become very difficult for us to test. Like, did we use this particular test hard drive? Did we use this controller? If you use a controller, what is the firmware version you used? There is so much of data people ask when they're seeing, customers are seeing observations. We are actually relying on our traditional test management solutions or a defect management solution. That become more difficult for us. And that's why if you look at what we have data is that if you take any traditional system, you will be looking at the metrics, like on all your performance metrics, memory, CPU utilization when you're testing, and then you have logs and all the stuff. Then you have hardware information like your cards, your network devices, your storage devices, their firmwares, and all this stuff. And then we also try to have some engineering artifacts like test drive, test management details, and defect management. All this data we wanted to place in one place so that we can able to correlate and visualize the data. At the same time, we can see later if you are going to do any deep dive analysis actually. So that's where we started looking at this problem statement. And yeah, when I started this one around like maybe 2017-18, I started to look at it. Then one of the major challenges that I looked at all the other tools, traditional databases, and all the proprietary tools and all the stuff. One of the major challenges I started seeing is that the volume of the data we get it, because we test hundreds of systems in a day, the events of logs or metrics, it's huge actually comes up to us. And somebody could be having an issue, then the OS will be generating so much of events, so we need to store, and they start asking the estimation. I told that it's very difficult for us to give estimation because we don't know, it can be uncontrollable. And the variety, I told you that there is so much of data, so many of variety of the data sets. We want to collect, some data will be coming directly using beats like that, some data we need to pull, some data we'll push, all those things. And the velocity, obviously, when you have so much of systems at the same time, same data from different regions when it's coming up, it's like too much of data over the traffic. So these are the couple of, I mean, this is traditional trees problem statement I'm talking. And yeah, we see some tools, in the industry there are tools are there, but some of the challenges what we have is the correlation and traceability. We wanted to correlate all this data in one panel. It's become very difficult for us because that won't support these tools like an Azure or some other tools what we have. And the last one, it's pretty expensive because the amount of data, whenever I ask something, they say that what is, how much is the size? Is it a GB? Is it a TB? What is the transaction data? I told it's we can't estimate, but if it estimate also, it's basically become very expensive actually. So that's where we started looking at what we can do. Can we build something, open source tools, and build by ourselves and start scaling up over the time actually, because we started at around like a 2-node cluster with Elasticsearch database. We did a lot of research to find out Elasticsearch is the final one. Then we took the Elasticsearch, then we started working on building this cluster, everything from the scratch. We buy the system, we bring the systems, we deploy the systems, we configure, then we create a cluster, we storing the data, see how it is storing, how much performance, how much data it's consuming. All things we did it, then we started looking at the things. So yeah, I'm just trying to show that number of events like logs, metrics. There is so much of data in a server. We'll be generating it, but what we do, and eventually when we see defect, there is certain artifacts we store, but we have so much of data actually. I think one of the biggest use case I try to sell this solution is that when we started testing, suddenly if the system got crashed and it's not even booting, what do? You don't have data actually. That's where I told that this will save us. It stores on the live actually. So if the system is crashed or if you wanted to look back after 6 months, the system data, you will be able to still access the data actually. So yeah, I think the first thing is that when we started looking at, we thought first word is that okay, let's try to use open source so that we'll have a lot of community, or we wanted to customize so that we can tweak what as per our needs. So yeah, Elasticsearch is basically the primary component in the system. Then we have a lot of other tools. We built a small front end to make users to access. Then we also use the Grafana majorly from the user side, because we have a lot of users try to access the data. So we wanted to control their access and control the dashboards and all the stuff. And also we have different data sets. So we try to use mostly the users who are accessing, they use through access through Grafana. Otherwise, we as administrators, we use Kibana to monitor the cluster and all this stuff. Yeah, otherwise Ubuntu, Postgres, these are all backend databases to store what the user is started, when they started, how the job is running, and all the stuff in the backend. And yeah, we try to collect and correlate metrics, logs, lot of data. Nowadays people start asking me that okay, they have a project, they are running a command line automation, they wanted to store each command line and its execution time and all the stuff, so that they can actually monitor build by build each command what they are running across teams, across programs, how it is getting actually execution happen. Is it like is it latency, how the latency is showing up and all this stuff. There are a lot of innovative ideas people are coming up now because we have a database. We told that the easiness of how we can store, how we can able to access, how we can view. There are a lot of use cases people are coming up with us saying that okay, how easy we can store it actually. And the best part of the thing is that a lot of people now pretty much knows REST API, so it's easy for us to write a simple code with JSON payload and send it into using REST API so that it will store it in the database. Yeah, the best part is that it's what we store is real time, so that people can able to access over the real time, and the cluster is high available, so that if one of the node is gone down, people doesn't even know, because we have replica storing across the systems, and then we have backup solution which takes every 30 days. And scalable, this is where I really interested, because I started with 2 nodes, then I keep adding nodes because the storage capacity what we needed is become more increasing day by day, and we keep adding more nodes in horizontally so that it's easy for us to scale up. Yeah, I think this is the first, when I think one of the customer came back and asked some data, it became very difficult for us to stay. That's where I started looking at it. I wanted to start simple simple database, query entire, scan entire database, entire lab, and every artifact in the lab, let me store it in the database. Actually, that's where we started saying that, okay, we will collect and store. We don't need to ask any user to give information. We will scan and we will store. That's where we started with 2-node cluster around 2018. Then we started seeing the importance of the data. People started observing the importance of the data. People, when they ask more queries, they go to know that what is it. Then we started seeing that, okay, we storing the data, but we don't know who is using, who is the user, what program, what config, what time frame. There are questions people started asking. Then we started designing the 2.0 with more enterprise class software type. Right now we are using 2.0 side, where we did is that we connected to the users, we created a nice front end where people feed information. Instead of we scanning it, people can provide the data to us. So we actually collect all the artifacts, and we are adding more advanced dashboards, correlation dashboards, all the stuff actually. So we are actually started an internship project where we are working towards the 3.0 version I'm calling out. So what we are doing now is that we are collecting the data, people are able to access the data over the Grafana. That's pretty good what they wanted, and then we wanted to have any historical data analysis, we can go back and search and all this stuff. But now we are looking at, like, okay, for example, if a user was running at 24 hours at testing, stress, and or the weekend, you don't need to go all the data over the Monday and all the stuff. So what we thought is that, what if we, in 24 hours, whatever happened in the system, using the LLM, we are actually exploring the Llama 3 now, to analyze all the logs, what it is generated over the last 24 hours with metrics. Can we give a summarization to the user that this is what happened in your system, and this process was actually consumed more memory and CPU over the time, like that, so that user don't need to go to all the logs for the 24 hours manually. Then we can give a summarization. That's what we are working on now. We started just a small POC with Linux and some of the Windows logs with the metrics and other stuff actually. So once we're done, mostly it will be like, user don't need to monitor by stuff. He can able to get alerted. We can able to look at more detail and all that stuff actually. So that's what we are working right now actually started. I think this slide is pretty standard, but I just want to tell you how the way we use it actually. I think I don't know, lighter is there. Yeah. So I think this basically pretty much standard. We actually use whatever the Elastic Stack is giving in a standard way, and wherever we have some things to get more data collection, we write our own things actually. For example, we use the beats, basically the Windows logs, metric beat and all the stuff, and we send the data directly to the database, Elasticsearch, and then at times we had some firewall issues because of the different regions, different labs. Then we start sending to Logstash, which is an open port based solution. Then we send back data to that. We tweak everywhere if it's something is blocking. We change the ports, we change the things, and then we start collecting the data and we send it. So one side, that's pretty good, where you have a OS, you can collect the data, but certain places we don't have OS. Okay, so that is the places where we actually use syslog server. Basically, that's traditionally the syslog server goes back to Logstash, and Logstash we have filters using grok parser and all the stuff, and that data will be storing back into Elasticsearch. And then there is places where we don't have OS and the device won't send data to us, where we actually query the data every 24 hours once or every 4 hours once, based on the frequency and based on the importance of the data. We write external programs for every node, and we collect the data and we store it actually. So basically there are certain data live, there is certain data we pull based on the importance and based on the criticality actually. And all the data goes back into Elasticsearch, and people will be accessing, we will be monitoring the cluster and all the stuff, and we have a Zabbix solution which monitors the cluster and alerts us or the teams to know if there is anything happened wrong and all the stuff. Otherwise the users will be logging into Grafana, and they will be accessing the data over the Grafana, and we create groups of users to access particular dashboards, particular data. That's why we simply do it. We don't add any security of Elasticsearch features. We just send data whatever we wanted, then we expose the data only to users who would like to see the data in the specified dashboards actually. Okay, I think I might have a couple of more slides, that's it. So yeah, just overall the skeleton, how it looks like, and top to bottom, bottom to top actually. For example, we have our own servers with data nodes, all the Elastic standards actually, data node, master node. We have actually Ubuntu installed on all the systems. We try to use Dockers also to make the Elasticsearch installation more easy and all the stuff. Then these are the physical servers where we have, and then we install all the things. Then we have connected to a cluster of systems, and this is the major one. We actually try to collect all the standard supported OSS data collections. like SUSE, Windows, all the stuff comes with the beats. The only thing is basically the VMware. VMware doesn't support the beats, so we actually try to reach to the Elastic community and all the stuff, and finally we figured out that we have to write our own beats actually. So we have written our own beats in Python. Actually, no, I don't want to say beats actually. It's a Python script which collects all the VMware metrics and send it to the Elasticsearch database. We use same key names, what metric beat uses, so that people doesn't know that it's a Linux OS or it's ESX OS. We just use it. We know that every key what we are using in the dashboard. So we collect the same data and we send it to the Elasticsearch in the same key names, so that people can seamlessly see the same dashboards for across OSs. That's things. And then we have I think these are the logs, metrics, and all the stuff. This is basically the specific hardware configuration of a system. We have like a 3,000 to 4,000 keys for a server, like storage controller, memory, CPU, all the data actually we collect and we store it every 24 hours of a system, so that we know that every day what is happening on the system and all the stuff. And then this is the new thing, where once we started showing that, people are asking that, okay, can we store the automation data? Somebody came back and said that we wanted to store automation data and see that how it is running. And we know that we will monitor in the test management, but what if somebody was running offline and he was not updating, but we wanted to store? So what we did is that we added a plugin into the automation framework itself, so that anyone, anywhere, anytime they run automation, it automatically logs into ICEMAN, our database, and visualizing the people, okay, so that they can, somebody who is actually a developer, who can monitor anywhere anybody runs it, so that he can see that how it is running, is there a failing, passing, not asking anybody user actually. So that's what we store. Then we started looking at more requirements coming up, saying that we want to store command line automation and all the stuff. And then we also started storing the Jira defects and the Q-test data what user is running, so that what we try to design is that we try to design a we design dashboard where the user can actually put his test plan, what he is running, then in the same timeline chart the defects what is showing up, then in the same timeline how the system is performing, what type of logs he is seeing, so that if there is any error was raised, it got detected on the system, easy failed a test case or not, and easy is that guy was actually failed test case, I updated defect and all things. So it's like there are different data sets, one from the test management system, one from the Jira defect management system, one from systems, one from hardware logs. We try to create all the data with a key mapping, and then we are visualizing that in one dashboard, so that user can see his timeline of his entire system actually what's happening. It's not only for user. When we are looking for historical analysis, we know that, okay, he was running this test case, this was the event was generated, e.g. filed a defect or not, all the stuff. So that's where, and I mean that one more interesting aspect also we did is that I know a lot of people are working on AML and Jira duplicate defect identification and all the stuff. What we also designed is that now we have a across system, we know the defects, we know the logs, we know all the things happen. When user got any event, he can go back to the one of the dashboard and he searches for the particular keyword. He knows that how many times the event was generated across configurations, across teams, across projects, and how many test cases was failed with the same reason, how many defects really opened right now, so that you don't need to file a duplicate defect, because we have all the data in Elasticsearch right now. We just need to just give a semantic search or a keyword search, and he is able to get the data actually. No what you call AML or nothing, it's just a simple search and he can able to see all the data actually. And then I think these are the things simple. We told that basically whenever we have beats, we install the beats. Whenever we don't have beats, we get the data to Logstash and send it. Otherwise, we write our own Python programs to collect. One of the examples is that GPU's data collection. I think beats was not there, so we started writing our own scripts to collect the GPU data for NVIDIA, Intel, AMD, and we started sending the data back to our database to visualize the data actually. We used majorly Elasticsearch cluster. I'll show you some insights about what we have, the cluster size and all the stuff. Otherwise, the Postgres is basically the back end of jobs, monitoring and all the stuff. These are all the UIs, some that interfaces, some interfaces user will see, some is basically for us back end actually. Grafana, Kibana, Flask and or React API, React front end we created for all the stuff. Source code in GitHub, Confluence for the documentation, and Jira for user defects and all the stuff. This is a high level technology stack what we have for this particular solution. I think one thing I forgot, I don't know, maybe I didn't show that. What is the name? How do you got it actually? I don't know. Sorry. So yeah, the name I put that information collector and monitor analyzer, then I'd go my ICEMAN. I didn't put anything. I just told that these are the words for me, the tool. So just generate a name, it's generated, and I started using that actually. Okay, if you have a doubt that how I got this name, yeah. Last fact actually, this is the one. We started with 2 nodes, 1 engineer, just a POC pilot project for saying that the data is important and we need to store and we need to have the data for the historical analysis as well. Now it was like a 30 node cluster running between US and India, okay, and we have Dell, we are from the server group, so we don't have issues picking up servers more and all that stuff. Yeah, and around like I think 400 terabyte storage capacity we built it actually. So right now we have 400 terabyte storage, and then we actually collected up to now 200 terabyte already actually the data. Rapidly we're getting the data. We are putting some archive policies so that we can delete the data which is not required. For example, the metrics, people may not look at metrics once it's over, but the logs they search, they look at further historical analysis and all the stuff. Yeah, we have 400 plus users accessing across regions to daily they use the data and it comes to us. And yeah, right now we have 300 billion data points. This was the one thing I tell that we have a lot of data points we will be using in the future, could be for the machine learning training model, or we will be using that for inference for the data analysis actually. I think, yeah, this is last slide, basically it's all the stuff, okay. It's basically become like an all-in-one monitoring and management tool for us, and it's basically for us central logging, everything we log there. It could be system, it could be automation. We are trying to put as many as things what we wanted, we store it and run things. And whenever the user wanted to correlate the spikes, he has a one place to look at everything, not like in different places for different logs, different places for different metrics actually. And the last one is, for example, for us is that I can able to easily trace down any historical issues, anything we got it, easily we can look at it actually. I think that's what metrics, logs, events are all together in one place. Okay. Yeah, any questions, feel free to ask me.
Hi, why Kibana and Grafana both?
Okay, when I started working at Kibana, if you want security, you need to go for license and all the stuff. To get into license, I need to a lot of routes I need to go. For me, I think if you look at the thing, I look at quick, fast, easy to people to start using, okay. I think keep it simple, stupid. That's what my policy. So I started looking at wherever I can do it, we do it faster so that people start using it. That's the reason. Otherwise, no specific. In Grafana also, it's a very, I think, community edition only, nothing enterprise. Okay.
How security is handled between Grafana and Elasticsearch?
Right now, basically what we did is that from our lab is completely restricted to VPNs and all stuff. Nobody can externally come up, but we know that some smart user can get into Elasticsearch. So that's why we told that Kibana is completely protected with the things. They can't access outside. Only Grafana can access the data of Kibana. And there's one thing we did it actually. We have HA proxy. I think some of you guys may know HA proxy or Nginx actually. So the HA proxy, what it do is that when you get the data, it will insert it. When somebody sends a delete, post, act something, it blocks actually. So only delete, post commands I can do only from Kibana, which directly access things. That's one thing we did it so that nobody can able to delete by mistakenly if they know Elasticsearch IP address also, because HA proxy blocks it.
Okay. One more question. 16 nodes are there, and you have
30. Yeah.
30. Okay. 200 terabytes of data. How the scaling happens?
So basically, we actually created a data intensive nodes, not like too many nodes. We have like in each node capacity, like, and we started with 20 TB data nodes. Right now, the node recently we populated is like 100 terabyte of data node actually. We try to scaling up the nodes at this point of time like that, whatever the capacity we have available in the right now system can capable. That's why we are scaling. But otherwise, we don't have any mechanism. Just you know that there is a need for the things, there is a growth. We have a budget allocation, just populating. It's all owned by us, managed by us actually. It's self-sustained, self-driven.
You mentioned that on VMware to pull the data, you are using Python script.
Yeah, just written a Python script.
2 questions on this. First one, is this Python script available on GitHub?
I can discuss. I can check it out. Yeah, there is a
because that was interesting. Yeah, I need it for some other purpose, but not from VMware. Question number 2, why didn't you consider using SNMP traces?
Yeah, I think SNMP traces, we have explored it, SNMP traps, SNMP traces for the data collection and all that stuff. Somewhere what happened, no, there are a lot of restrictions, a lot of installation things we need to do, exploring. For us, basically what we are programmers, we thought, okay, let's do it in Python actually. Okay, in a simple way if you ask me. And we know that we will need to add more and more things, so that's where it end up. And again, VMware is a little bit complicated way to do things, because once you reboot things, it will erase it. So we have to write something which can move to the temp and partition, then it come back actually. I can share you the details of it. It's it's a Python script, right? There is nothing confidential.
When feel free to contribute.
Yeah, absolutely.
All right, yeah, I saw a few hands here. Yeah.
Is that from a lot of logs we are taking from the VM? So is it any affecting our VM performance like that? Like our lead said, like several years before VM, they get used to get lot of logs from the VM. It get down that VM and it got that P1 issues, right?
Absolutely. I think one of the question when I populated this project, correct, when I was done scanning everything, nobody knows. When we started telling that, okay, we build a solution which can scale everything, install everything, collect everything, they started asking that how much it can impact the system, and we're testing actually. So we started monitoring it. One of the best part is that Elastic Beats was not consuming so much. Okay, the beats or metric beat and all things are very optimized way they written. We are a little bit worried about our code, what if it is generating memory leaks. So we did a lot of monitoring and all this stuff, not making sure that crossing and all things. But at this point we are not actually using much power, because they are pretty powerful servers what they're testing. It's like in a 0.1%, 0.2% relation we get it actually. Yeah. Yeah, please.
So in case of root cause analysis, so the primary requirement is the training data set. So how you are automating it? Like if the string contains error and all those things, it's very easy. But usually what we see in our products, it's event sequence and all those things.
Absolutely.
So how you find that one, or how you solve it? Is there any unsurprising?
Literally, we have not started. Okay, let me put it very
So
straight.
that's the major challenge.
Okay, right now I told you that it's just a postman job, get the data, show to user. Okay, but now we are trying to tell that, okay, if I use LLMs, can it give some more information about the usage and all the things?
Yeah.
We just baby steps, I think it's very simple way. Okay.
And related to Grafana and the Kibana, right? So Grafana, just to visualize, it's very good. But we see Kibana has advantage over the aggregations. So it gives more analytics and aggregation. So do you feel Grafana is comfortable?
Actually, first is I given the Kibana access for users. As they started randomly searching random things, and it was impacting things, then I thought, okay, how do I do? Okay. We have dashboards, but anything can access. Then I need to go to security, then I need to go to licensing. Then I thought it's very simple. We design the dashboards, let them access the things. If there is anything out of that, we will take care using the request, Jira, Record and all the stuff.
Yeah, so Kibana is more of engineering dashboard.
Yeah, it's engineering for us. So, we monitor Kibana, we use the Kibana, we have a dual instance of Kibana and all the stuff. But that's not for the end user actually. It's only for us to look at the cluster health or the sync the nodes, or using the dev tools more frequently to do things and all that stuff.
Okay.
Yeah.
Fine. Thank you.